In this video, I'm just going to review a few basic concepts from the radical unit. So, there's two different forms. These are in rational, which means fraction, rational exponent form. So notice again, we have a fraction in the exponent position, rational exponent form. If we want to put them in radical form, the 27 is separate from the x to the 4/3. They're two different things. Here the 1/3 applies to everything inside. So 27 is going to remain outside. The x goes inside. The bottom number is always the nth root, and you have two choices with the 4. The 4 can go in this position, or the 4 can go on the outside and above. Either would be accurate. Now for this expression, the 1/3 applies to everything on the inside. So the bottom number goes inside, 8x squared goes inside, and I have a 1 on top. And we know that raising everything to the first power doesn't change the value. So if you wanted to, you could also express this expression like this. I'm going to simplify this radical expression, and as I simplify it, every time it needs to be equivalent to this original. So I'm going to write down all the things that it is equivalent to. So if I rewrite this, this is in radical form. Rational form says the nth number, regardless if it's larger or smaller, goes in the bottom. 15 goes on top. So these two are equivalent. I know that this also reduces down to 3/2. These three are equivalent. And I know that I can rewrite this in radical form with the nth root going on the outside, x is on the inside, and I have two options here for the 3. The 3 can go in this position, or it can go on the outside above the. I'm given an expression and I'm asked to simplify it. As a reminder, let's take this concept and let's apply it to something I feel that you understand. So if I gave this to you and I said, all right, let's reduce or simplify this expression, you'd think to yourself and go, okay, I'm multiplying the x's. When you multiply and they have the same base, you would add the exponents. So 2 and 3 is 5, 5 and 5 is 10. When you divide and you have the same base, you'd subtract. So 10 minus 4 would be 6. This original expression is equivalent to x to the 6. So we're going to do the same thing, but I'm going to use the calculator to help with this. So I'm going to rewrite it. This is in radical form. Radical, radical, radical. This is rational exponent. I think it's easier to put them all in the same form. So on top, I have x, and remember, when I'm multiplying the same base, I'm going to add the exponents. So this has a hidden 1 here. So this is the nth root goes on the bottom, so 1/3 plus nth root goes on the bottom, 3/2 plus 7/8. Down here, this is a hidden 1, nth root goes on the bottom. Now the calculator does the rest for me. I'm going to make sure to use parentheses. I have 1/3 plus 1/2 plus 7/8. Turn it back into a fraction, 41/24. Again, x to the 10th or x to the 4th, I subtract to get x to the 6th. I'm going to do the same thing here. So on top, 41 divided by 24, subtract 1 divided by 5. Turn it back into a fraction, and I have 181/120. This is equivalent to this original. Okay, now we're going to shift from simplifying expressions to solving radical equations. What unique value of x can I substitute in, and the left side will equal the right side? Whenever the nth root is even, you must always check for extraneous solutions. Whenever the nth root is even, you must always check for extraneous solutions. Okay, here we go. I'm going to subtract 7 to the opposite side. 2 subtract 7 gives us -5. This is like a -1 out front. I'm going to divide by -1. And the square root of the quantity x plus 1 equals 5. Now when you don't see a number here, it is a 2. So just like opposite of adding is subtracting, opposite of multiplying is dividing. So the opposite of the nth root, because this is really written as a 1/2 if you want to think of that, is we're going to square both sides. Opposite of square root is a square, and they simplify to a 1. I subtract 1 to the opposite side, and now I have to check for extraneous solutions. So let's try it. 24 plus 1 is 25. The square root of 25 is 5. 7 minus 5 is 2. That works. When we work with nth roots that are odd, it can produce both a positive or negative final answer. I'll show you that in the next example as well. In those cases, we don't have to check for extraneous solutions, but I will show us. So just like over here, when the nth root was 2, I raise it to the second power. When the nth root is 3, I raise it to the third power. 2x equals, well, 8 times 8 times 8 is 512. If I divide by 2, I get an answer of 256. If you're unsure about that or you forget this rule, you can plug 2 times 256 back in. So 2 times 256. Now, how do we type in the nth root of 3? Remember, this is the same as 1/3. So I could put 512 in parentheses.
A reminder to all of our staff, we have some free breakfast items to thank you for your hard work this week. The breakfast items may be picked up.
So here, the first thing to ask yourself is, what is the nth root? And if you don't see the nth root, we know it's a 2. When it's even, I do have to check for extraneous solutions. When it's odd, I don't, because the answers can be positive and they can be negative. All right, here we go. What do I do? Well, to get rid of this nth root of 2, I raise both sides to the second power. And I'm going to move everything to the same side as the x squared. So I'm going to move the x over and the 20 over. And now what multiplies equal negative 20 and combines to give us a negative 1? 1 and 20, 2 and 10, 4 and 5. This will be the sign of the larger number. And because the leading coefficient is a 1, I don't have to worry about it. So I'm trying to solve. Okay, here are my answers. Remember, whenever this is an even number, I do have to check for extraneous solutions. So let's check. I'm going to plug in 5. This is to the original. The original looked like this if it's confusing because my handwriting is messy. 5 plus 20 is 25. The square root of 25 is, in fact, 5. This works. Negative 4 and 20 is 16. The square root of 16 is 4, not negative 4. Those are not the same values. Okay, again, the directions would be to solve. And I do have an nth root. That's always the bottom number. I do have an nth root that is odd, which means I should not have to check for extraneous solutions. Okay, here we go. I'm going to subtract 11 to the opposite side. 2 equals this quantity. How do I remove the 1/5? I raise it to the reciprocal. The reciprocal of 1 over 5 is 5 over 1. 5 over 1 is just 5. Now 2 to the 5th, I often see students when they're trying to work quickly, they just write down 2 to the 5th is 10. Not the case. 2 times 2 times 2 times 2, 5 times is 32. Moving 1 to the opposite side by subtracting. 31 equals 2x, divide by 2, divide by 2. I get 31 over 2. I should not have to check for extraneous solutions because I have an nth root that's negative, but how could you do it? You're unsure, we want to make sure you get it right. What can we do? Okay, here we go. 2 times the quantity, 31 divided by 2. Then I add 1 to it. After I add 1 to it, I have 32 raised to the 1/5. Make sure to put that fraction as an exponent in parentheses. Add 11, and I end up with 13. Okay, so I'm going to solve this problem. Notice that the nth root is even, which means I should check for extraneous solutions. And if you're like, I'm not getting that, think of this. If I take, for instance, well, let's just go through this and show you an example of how it does. I think that would be the easiest rather than showing you multiple singletary examples. So negative 2 and negative 2 is negative 4. Now, how do I remove the 1/4 that's in the exponent position? I'm going to raise it to the 4th. Make sure you use parentheses. Remember, they don't just disappear, they reduce down to a 1. And now I'm going to take negative 4 and raise it to the 4th. I have to put the negative 4 in parentheses. When I raise it to the 4th, I end up with a positive 256. Subtract 4 to the other side, I end up with 252. Let's check and see from the original if that's correct. 252 plus 4. Okay, I'm going to take 256 as I have it. I'm going to raise it to the 1/4 in parentheses. And I'm going to add 2, and I end up with an answer of 6. I'm going to try one more time to make sure I've done that right. That's why we check whenever we have an nth root that is even. So I have 252, add 4, raise it to, in parentheses, 1/4. I add 2, and I get an answer of 6, not an answer of -2. What does that mean? This is an extraneous solution, and there is, in fact, for this problem, following the rules, the nth
Good
root.
morning, Bruin.
So sorry.
Happy Friday.
The
This
nth root
announcement is for
is
students taking the AP United States History
so you
exam.
should not have
Please
to check.
report to the community room at this time. Once again, students taking the AP U.S. History exam, please report to the community room at this time. Thank you and have a great day.
Okay, now to remove the 1/3, I'm going to raise it to the 3/1 power. Remember, this just reduces down to a 1. And now you have to put this in parentheses. -6 raised to the 3rd, and I get a -216. Okay, I'm going to add 2 to the opposite side, and x equals -214. Now let's check. According to this rules, it should work, because with odd, you should not have to check for extraneous solutions. Okay, ready? Here we go. So I look up here, and in parentheses, I type in -214, subtract 2. I raise it to the 1/3 power. It has to be in parentheses, or it won't correct it. I add 5, and I want an answer of -1. If this is true, then this works. Oh, you know what? Let me see if we can do another one, because this is so far back. Let me see if we can get another one here. Let me do another one for you that's not as large. It could have had an answer there of -1, but it goes into a rounded system. So hold on one second. Let's do this exact same thing. I'm going to make it a little bit smaller number. Okay, let me do the same thing. Okay, to the 3rd, to the 3rd. Now, I know that -3 to the 3rd, -3, whoops, to the 3rd is -27. And I add over, I should get -25. Now, I'm baffled if this is not going to go in. Okay, here we go. So I have -25, subtract 2, raised to the 1/3. Now, there we go. When I add 2 to it, we get an answer of -1. So it does work. I think that my calculator has rounding issues here, but I just want to go over that one more time. You may be watching this and you're seeing a mistake I made in itself. Okay, so I'm taking the -216, raising it to the 1/3 power in parentheses. Maybe I forgot that. Okay, I got a -6. So I obviously just plugged something in wrong. I'm not sure what I plugged in wrong, guys, but the top one did work. The point is, when your nth root is, the bottom number is odd, you do not have to check for extraneous solutions, because you could have positives and negatives. Once again, this is -212, subtract 2, -216. I do have to put it in parentheses. Raise it to the 1/3 power in parentheses. That's this portion I've done. When I add 5 to it, I do get an answer of negative. And another problem, you're asked to identify the domain and range. They give you a formula. Feel free to plug this into decimals. I'm going to do a quick sketch. This lies to me, so I'm going to go to the left 3, 1, 2, 3, and down 2. And now I'm going to make this general picture of what this looks like, okay? This is the general picture. Again, you could get that by plugging it into Desmos. Now, what is the domain and what is the range? So domain, it starts at an x value of -3. I have to include it, and it goes to the right. The range goes down as low as -2. I have to include it, and there's no limit how high it goes as it moves. In this particular problem, I'm going to describe the translation of what you see in black. We're going to call this f of x to what we see in orange, which is g of x. So first it translates 1, 2, 3 times to the left. So it goes 3 times to the left. So opposite of which direction we think, so I'm going to write x plus 3 inside, and then it goes up once, of 1. So this would be the equation of g of x. From the parent function, it goes to the left 3. And okay, let's talk about other transformations. So this is the basic parent function. If I wanted to show that this function is moving to the right 1, it lies just on the inside. So this would actually be to the right 1 unit. If I wanted to show it goes to the left 2 units, to the left 2 units, it lies just on the inside. So those are horizontal shifts. If I wanted to show that it goes up 2 units, I take the basic parent function and I go up 2. It tells the truth. Up 2. If I want to show that the parent function goes down 5, behind the radical symbol, I do a -5. Horizontal is inside, and it lies to you. Vertical is in back of the radical, and it tells the truth. Now, what about numbers that are in front? What do I mean by that? So when you have like a 2 in front, it means that it is skinnier. We use the word stretched. We use the word stretched if it's in front. Okay, it's stretched by 2. It's a skinnier version, stretched by 2. And if the number would be between 0 and 1, we'd say condensed. Condensed, it's a flatter version. It's a flatter version, but they use the word condensed. That's the math term they use to describe. What happens when there's a negative that goes in front? So a negative in front means that we are going to reflect across the x-axis. Reflect across the x-axis. Okay, so what we're going to do now is we're going to find and identify what is the inverse of this. So algebraically, how do I find the inverse? And then how do I identify the domain? There are a couple different ways we can do that, and we can use Desmos to help us. We are going to then prove using composition of functions. They are, in fact, inverses of one another. So remember, this is really like a y. When we find the inverse, the first thing we're going to do is just switch the x and y's, and then isolate the y. So I add 3 to the opposite side. Then to get rid of the square, I take the square root. And so I think, and I'm going to call it g of x. I'm going to call this the inverse of f of x. I think g of x is the square root of x plus 3. The square root of x plus 3. The second question is find the domain of the inverse. What we learned earlier in the year is that the input, the input is your x values. The input of the original function, in this case it is f of x, becomes the output or the y values for the inverse. And the y values or the output of the original becomes the x values of the inverse. I think it's easier just to see that by actually graphing it. So I'm going to come in here and graph this. This is the original function. And it specifically said, if you looked here, it specifically showed I should only do it where x's are greater than or equal to 0. So how do I do that? I'm going to come over here, make these squiggly lines, and I want x's greater than or equal to 0. Okay, so I'm just following exactly the criteria that I was given. Okay, this is the original. This is the original. And I do want to show this because I think verbally when I just repeated the rules, I think it's really hard to understand. We can see that the x's go to the right of 0, include 0. So if I had to look at this original, I'm going to write down f of x. I can see that the domain are 0 and to the right. And I can see the range, if I come back here and look, the range is at -3 or above. It's at -3 or above. Okay, there's the domain and there's the range. All right. All right, now let's go and let's plug in what we have for our inverse. So we came up with, when I did the math, we have the square root, it's right down here, and x plus 3. And now let's look at this. So okay, so for the domain of the inverse, which is in blue, it's -3 and to the right. It's -3 and to the right. Okay, so I'm going to write that down. I come back over here. Remember, g of x represents the inverse, and the domain is -3 and to the right. And then I'm going to, okay, now I'm going to do the range. What's the range of the inverse? So in blue, it's a y value of 0 and greater. A y value of 0 and greater. And this is what I was verbalizing. It's hard to conceptualize it without seeing it. See how the domain of the original becomes the range of the inverse, and the range of the original becomes the domain of the inverse. That will always happen for you. So what we've done so far is we've identified what the inverse is, and we've identified the domain of the inverse. Next is we're going to use composition of functions to prove that, in fact, these two are inverses of one another. So I'm going to write this down. We're given that f of x is equal to x squared minus 3, and g of x is equal to the square root of x plus 3. How do we do composition of functions? So we do have to show it both ways. What does this mean? It means write down what f is. Okay, so I'm going to write that down. And wherever you see an x, stop and leave a parenthesis. Now, inside that parenthesis where you saw an x, you're going to place what g of x is equal to. Okay, let's go through the motions here. I know the square root and square are going to simplify to 1. I know positive 3 and negative 3 add to 0. So this quantity equals x. Awesome. If it doesn't, I stop. And I've just shown that they're not inverses. Okay, it has to work for both to prove algebraically that they are inverses of one another. Now I write down g. So g is equal to the square root. Wherever there's an x again, I put a big parenthesis. Inside of that parenthesis, I put what f of e is equal to. And now I'm going to do the algebra. Negative 3 and positive 3 add to 0. The square root and the square are going to simplify to 1. And here we go. I'm left with just x. I just proved algebraically that the two are. Another way you may be asked to show, if I come back to this graph here, is recall that if I type in y equals x, I can always go up here and hit the little symbol that looks like a year. Remember that when we talked about this last fall, that the two functions, when they're inverses of one another, directly reflect across the line y equals x. And I can visually see that, right? They're the same distance from here to here as it is from here to here. That may help us if we're just going to do a rough graph. If I just had a graph here, and let's say this is the graph. So I'm going to go 1, 2, 3, like, there we go. If I have this and I'm told, and let's say it looks like that, and I said, okay, without doing any math, they want us to sketch a graph of the inverse. The first thing I would do is I would graph the line y equals x. And then, in the best estimate, okay, this distance, this distance, this distance, this distance, this distance, this distance. And now I can see this is a sketch of the inverse. Okay, so what we're going to do next is we're going to take a look at this graph, and we are going to analyze it in multiple ways. So let's start with just identifying things like, where do we see, if you can identify, where do you see the constant? Where do you see it increasing? Where do you see it decreasing? So I'm going to take one similar to what you're doing here, and give me a second to plug it in, and then we're going to analyze that. So I can come up here. You're welcome to watch me do this. Okay.